Hi everyone. Now we are going to discuss about a topic called antiviral agents or antiviral drugs. So we are having the two types of antiviral agents or antiviral drugs, interferons and base analogues. Okay, so we will discuss the base analogues in this part. So first of all, what is meant by antiviral agent or antiviral drugs? The chemical substance or the drugs used for the treatment of viral diseases are called antiviral agents or antiviral drugs. That means whatever the chemical substances or the drugs which are going to be used in the treatment of viral infections or diseases, these are all being called as antiviral agents or antiviral drugs. We are having the several types of antiviral agents, but basically we will discuss about interferons and the base analogues. The interferons were already discussed in another part. In this part, we will discuss about the base analogues. So what are base analogues? Base analogues are structurally similar to purine and the pyrimidine bases. That means our nucleic acid is going to have or any nucleic acid is going to have the two nucleotides, that is a nucleic acid contain nucleotides, that is purines and the pyrimidines. Those are going to be called as nitrogen bases: adenine, guanine, cytosine and thymine. So these are essential to build up the nucleotides and then to form the nucleic acid. So the base analogues are structurally similar to the purines and pyrimidines, that means nitrogen bases, which are required for the synthesis of nucleic acids. Okay, so some of these analogues, that means they're structurally similar to the purines and the pyrimidines, but their function is totally different. So those are being called as analogues. And these base analogues will compete with the normal bases for incorporation into the newly synthesized DNA. Now what happens? The later thus come to have the analogues and are functionally ineffective to structurally stable. So obviously the DNA cannot replicate even if they replicate from incomplete or non-infectious virions. So they won't, though they are going to try to replicate also, they are not going to have any capacity to cause the infection, and that's how becoming the non-infectious virions. The examples of some of the base analogues are Acyclovir, Cidofovir, and then Ganciclovir, Penicillin, then Vidabrine. So these are the few examples. Let's see their structure and function. So the first one is the Acyclovir. So this Acyclovir is going to has become the most widely prescribed and clinically effective antiviral drug available till date. Okay, and this is going to be a synthetic acyclic purine, that means analog of a guanosine nucleoside, and then it is selectively inhibits the replication of some of the viruses like HSV, that is herpes simplex virus, and varicella zoster virus, even the Epstein-Barr viruses. Now see here, this is a guanosine structure and this is a acyclovir structure. They are structurally similar in the thing, but when this acyclovir is getting incorporated into the replication process, so the DNA is not able to have the replication as it is a false nucleotide, and that's how the virus cannot grow further. And this acyclovir can be used in the form of a tablets, injections, ointments, everything. Okay. Then moving to the second type of base analog, that is Cidofovir. So this is a cyclic phosphonate nucleoside analog. So that means here this is your nucleoside which is going to have a phosphate. So that's why this is called as phosphonate nucleoside analog. And the drug has a similar mechanism of action of this acyclovir and as other nucleoside analogues, majorly as acyclovir, and it is also used to treat some of the diseases like CMV, retinitis, HSV, all these things. Okay, so further if we want to discuss about this, it is going to suppress the cytomegalovirus replication by selective inhibition of viral DNA synthesis, and it can be given in the form of injection Okay, used for the treatment of this cytomegalovirus retinitis in patients with especially AIDS, that is HIV infection. Okay, then moving to the next base analog is Ganciclovir, and this is a synthetic purine nucleoside, especially analog of guanine or guanine analog, and it is almost structurally and pharmacologically similar to acyclovir. So this is what. Okay, and it is active against the herpes simplex virus like acyclovir. Okay, but there is a slight difference between the gangliosir and the acyclovir is going to be of increased antiviral against the cytomegalovirus and less selectively for viral DNA. So that's the drawback. And this Ganciclovir is going to be of transformed into Ganciclovir triphosphate. So we are going to add the triphosphate to it by cellular kinases. And this activated phosphorylated form inhibits replication of the CMV and the other human herpes virus by interfering with the DNA synthesis through competition with deoxyguanosine and for incorporation into viral DNA by terminating the DNA synthesis. So in a simple term, it is a guanine analog, while the DNA synthesis, it will compete with the normal guanine, and it is, if this ganciclovir is going to be incorporated, so obviously there will be no DNA synthesis, that means no viral replication occurs. Then moving to the next one, that is idoxouridine and trifluorothymidine, and this is a thymidine analog. When administered, what we call it as systematically, it is phosphorylated by thymidine kinase to active triphosphate derivative, which inhibits the viral DNA polymerization, the same thing, the DNA synthesis. Now, this is going to be of more effective for the treatment of herpes simplex virus keratitis, that is HSV keratitis. Okay, then moving to the, so here you can see the figures and the pharmacology in the pharma industry, how they are going to be given for us in the treatment of several infections. Then penciclovir, that is penciclovir, it is a new member of guanosine nucleoside family and the derivative of famciclovir, and it is a good therapeutic for the therapy of both HSV, that is a herpes simplex virus, as well as the varicella zoster virus. Okay, then coming to the vidabrine, and this base analog is a purine nucleoside and analog possessing structural similarity with adenosine, okay, especially adenosine, and inhibits the DNA dependent DNA polymerase of some DNA viruses and also blocks the viral DNA synthesis. As I told you, this is also active against the HSV, that is herpes simplex virus, varicella zoster virus, and even the cytomegalovirus. Okay, then moving to the next one, zidovudine. So this zidovudine or azidothiamidine, AZT, this is also called as a azidothiamidine, is an analog of thymidine. Okay, analog of thymidine, and it is an antiretroviral drug that inhibits the action of reverse transcriptase. So we can use in the treatment of HIV. So the enzyme that HIV uses to make a DNA copy of its RNA. So zidovudine or azidothiamidine was the first approved drug to treat the HIV infections, that is AIDS. Okay, and this was major breakthrough in AIDS therapy in 1990s that significantly altered the course of illness and helped destroy the AIDS was an instant death sentence. Okay, so that means we can prolong the death by giving this zidovudine. We cannot stop, but we can prolong the death. That means we can stop the growth of virus without not going to have the more infection. That's how we can prolong the life of the person. Then moving to the next one, adenosine. So it is a purine nucleoside which inhibit the viruses like HIV-1 and HIV-2. Then moving to the lamivudine. So this lamivudine is an enantiomer of cytidine analog. So it shows a significant activity against the diseases like HIV and HBV, that is hepatitis B virus. So that's how these all base analogues are best widely used in the treatment of majority of the viral infections. So these are all the branded names or the different types of the medicines that we are going to possess these compositions. Okay, so that's all about the base analog. So we had gone through the Acyclovir, Cidofovir, Ganciclovir, then iodoxuridine, then penciclovir, then vidabrine and zidovudine, diadenosine and lamivudine. Okay, so these are all the few base analogs which are used in the treatment of certain viruses as a antiviral drugs. Okay, so that's all about the antiviral agents base analogs. Thank you.